All right, let's jump right into this explainer and talk about an absolutely fascinating, invisible force that's quite literally shaping our world. I mean, from the tiny atoms inside the device you're holding right now, all the way up to the massive scale of our entire planet, magnetism is just everywhere. It's this unseen power dictating how the universe interacts, and yet, honestly, we totally take it for granted every single day.
So to kick things off, let me throw a bit of a mind-bending question your way about two of the four fundamental forces in physics. If you had to put money on it, which force would you say is stronger, magnetism or gravity? We almost always think of gravity as this unstoppable, heavy-hitting force, right? I mean, it keeps entire oceans strapped to a spinning rock in the vacuum of space, and it keeps our feet firmly planted on the ground. But here's where it gets wild. A simple, tiny, everyday fridge magnet actually overpowers the Earth's gravity without breaking a sweat. Just think about that for a second. The entire mass of the Earth is trying to pull a paperclip down to the floor by literally tugging on space-time itself. But a tiny piece of magnetized metal can snatch that paperclip right up into the air just by pulling on charged particles. So yeah, magnetism, phenomenally strong.
Moving into section 1, the invisible force. To really wrap our heads around how this incredible power works, we've got to zoom way into the microscopic level. The whole secret sauce of a magnet is its microscopic organization. In almost everything around us, like wood, plastic, glass, the electrons are just spinning in completely random directions. It's total chaos in there, so their tiny individual magnetic forces just cancel each other out. But in a magnet, the molecules are uniquely arranged so those electrons are perfectly organized, spinning in the exact same direction. And that uniform spin is exactly what creates a definitive north and south pole.
And this force doesn't just stay trapped inside the metal. It flows outward. It pushes out from the North Pole and then wraps all the way around to re-enter through the South Pole in these continuous, looping lines. It basically creates this invisible, protective-looking sphere of influence right around the object.
We call that sphere of influence a magnetic field. Think of it as an invisible area surrounding the magnet that's just packed with stored-up potential energy. And this is where things get super interactive. When you try to shove two similar poles together, say a north pole against another north pole, that stored potential energy instantly turns into active kinetic energy. It violently pushes the magnets apart. But if you flip one around, a north and a south pole will be so intensely attracted that this same invisible field forcefully snaps them together.
Which brings us to section 2, a brief history of magnets.
Let's take a quick look at how humanity figured out how to harness this invisible power way before we understood the atomic science behind it. It's honestly a wild ride. Legend has it all kicked off in ancient Greece when a shepherd named Magnus got the metal nails in his shoes stuck to a naturally magnetized rock, what we now call lodestone or magnetite. Human ingenuity totally took off from there. The ancient Egyptians used hidden lodestones to make objects of worship float in mid-air, completely blowing people's minds. Over in ancient China, an emperor actually built palace gates out of lodestone, so invading soldiers wearing metal armor would literally get stuck to the doors. No way, right? Fast forward to 1600, scientist William Gilbert is publishing a manual on making artificial steel magnets. And then in 1820, Hans Christian Ørsted completely changed the game when he noticed a compass needle twitch near a live electrical wire. Boom, electricity and magnetism were linked forever.
All right, section 3, feeling the force.
So let's step out of the history books for a second and actually feel this force. You don't even need a science lab for this. You probably have the equipment in your pocket right now. Seriously, grab a pair of everyday earbuds and try to force the two earpieces directly together so they touch perfectly flat. You can't really do it. You'll instantly feel this physical, almost squishy resistance pushing back against your fingers. What you're feeling is the kinetic energy of the like poles from the tiny magnets inside the speakers repelling each other. You are literally feeling an invisible force field pushing back at you. How cool is that? Now, here's a fun fact. Not all metals are invited to the magnetic party. We kind of assume magnets stick to any metal, but that's actually a myth. Only very specific materials like iron, nickel, cobalt, and steel have the exact right atomic structure that allows their electrons to line up and react to a magnetic field. Other metals like gold, mercury, and copper, they just don't have that structure. You could hold the strongest magnet in the entire world up to a solid gold brick and absolutely nothing would happen. Let's move on to section 4, electromagnetism in everyday life. So let's scale things up. Remember Oersted from our timeline? His accidental discovery gave us electromagnetism. And the crazy thing here is just how deeply electricity and magnetism are linked. If you take a piece of iron, wrap a copper wire around it, and then run an electric current through that wire, you generate a massive magnetic field. And the absolute best part about this, because it relies on electricity, we can turn this super powerful magnetism on and off on demand, literally just by flicking a switch. It's a total game changer.
This exact brand of electromagnetism is what makes electric motors possible. By strategically pulsing electricity through that coiled copper wire while it's surrounded by regular magnets, we can force the inner cylinder to constantly repel and attract, which creates rapid rotational movement. And this one principle is doing a lot of heavy lifting in our society. It powers the electric toothbrush in your bathroom, the MRI scanner at your local hospital, those futuristic maglev trains floating above their tracks, and even those massive heavy lifting cranes you see tossing cars around at scrapyards. And finally, Section 5, Earth, the giant magnet.
Let's zoom all the way out. Forget fridge magnets and electric motors for a second, and let's look at the largest scale possible, our own planet. Deep beneath our feet, right at the center of the Earth, there is a solid core made mostly of iron. Surrounding that solid center is a massive swirling ocean of liquid iron. Because the Earth is rotating, all that liquid iron is constantly spinning. And since moving electrons in iron generate magnetism, our entire planet is basically functioning as one gigantic electromagnet, complete with its own massive north and south poles.
And we should be very, very thankful for this planetary magnetic field. First off, it's what makes compass needles always point north, which, has allowed humans to navigate the globe for centuries. Second, a ton of animals like migrating birds and whales actually have a biological sense for this field. They use it like an invisible highway system to navigate thousands of miles. But without a doubt, the most important thing is that Earth's magnetic field acts as a colossal shield. It wraps around the globe and literally deflects the deadly radiation and solar winds that are constantly blasting at us from the sun.
Honestly, without this invisible force pulling perfectly aligned electrons, our atmosphere would just be totally stripped away by solar winds. Life, as we know it, simply wouldn't exist. So I want to leave you with a bit of a provocative thought to chew on today. If something were to happen, and that spinning liquid iron in the Earth's core just stopped, if our massive, invisible magnetic shield vanished tomorrow, how exactly would humanity survive? It's a pretty staggering question, and it really puts the true invisible power of magnetism into perspective. Thanks for joining me on this explainer, and keep questioning the invisible forces around you.